In Hunter x Hunter, every living being has aura, a kind of life energy that flows through the body. But what makes someone a Nen user is the ability to control that aura with intent. And here's what makes Nen interesting. The energy alone doesn't determine what someone can do. What matters is how that energy is categorized. Every Nen user has a type: enhancer, emitter, manipulator, conjurer, transmuter, specialist. Same raw aura. 6 completely different ways of using it. Gon is an enhancer. Killua is a transmuter. Kurapika is a conjurer. They all have aura inside them. That's the same. But what they can do with it is determined entirely by their type. An enhancer can't suddenly start manipulating people. A conjurer can't transmute their aura into electricity. The container is the same. The contents work differently because the type is different. That's exactly how variables work in programming. And once you see it through this lens, types stop being a rule you have to memorize and start being something that makes obvious sense. Let's start from the beginning. When you write a program, you constantly need to remember things: a player's score, a user's name, whether a door is locked, the price of an item. None of that can live as fixed text inside the code, and because it changes. Programs need a way to store information, give it a name, and come back to it later. That's what a variable is: a named slot in the computer's memory that holds a value you can use, change, or read whenever you need it. That single line does 3 things at once. It picks a type, int, which means integer, a whole number. It picks a name, score, and it assigns an initial value, 0. From this moment forward, the program has a slot in memory called score that holds the number 0. Anywhere else in your code, you can use the word score to mean exactly that value. This is what gives a program memory. But notice something. We didn't just say create a slot. We said create an integer slot. That's the type. And in C++, types matter deeply. Just like Gon can't suddenly use Killua's transmuter abilities, an integer variable can't suddenly hold a piece of text. The type of the container determines what fits inside it and what operations are allowed. There are a handful of fundamental types you'll use constantly. Let's walk through them. Int for whole numbers. Scores, counts, ages, levels. Anything that doesn't need decimals. Double for numbers with decimals. Prices, percentages, distances, anything continuous. Char for a single character. 1 letter, 1 symbol, 1 digit treated as a character. Bool for true or false. Just 2 possible values, but it's the foundation of every decision a program makes. String for text. Words, sentences, names, any sequence of characters. 5 types, 5 containers, each one designed for a different kind of information. And the type isn't a suggestion, it's a contract. If you declare something an int, the compiler will refuse to put text in it. The container has rules. This is the Nen system in code form. Same fundamental idea, energy stored in named slots, but the type is what determines what's possible. Now here's where it gets interesting. A variable isn't just a place to put a value, it's a place where the value can change. The slot is the same, the name is the same, the type is the same, but the value inside it changed 3 times. That's the whole point of the word variable. It varies. This is the moment your program starts feeling alive. You can write code that responds to what happens, a score that increases as the player wins, a health value that drops when they take damage, a timer that counts down. Each of those is a variable being updated as the program runs. Think of Killua's electricity. He didn't always have it at full strength. He built it up over time, training and refining his transmuter ability until the value of his power increased. The container, Killua himself, stayed the same. But the value inside grew. It's variable assignment. But sometimes you want a value that can't change. Something fixed. Something the rest of your code can rely on never shifting underneath it. For that, C++ has constants. The keyword const locks the value in place. Once max health is set to 100, no line of code anywhere in the program can change it. If you try, the compiler will reject your code outright. This might sound restrictive, but it's actually one of the most powerful tools in programming. Constants protect you from yourself. They tell the compiler, and anyone reading your code, this value is sacred. Don't touch it. In Hunter x Hunter, every NEN user has a fundamental type they're born into. An enhancer is an enhancer. They can train, they can learn techniques from neighboring categories, but their core type doesn't change. It's a constant of who they are. Constants in your code work the same way. Some things should be permanent. The maximum number of players in a game, the speed of light, the number of days in a week. These aren't things your program should be allowed to change on a whim. There's one more thing about variables that most beginners overlook, and it's the thing that turns variables from a feature into a craft. It's the names you give them. This code works. The compiler is perfectly happy. But 6 months from now, when you come back to this code, you will have no idea what X, Y, or Z were supposed to mean. Now look at this. Same logic, same operation, but this code tells you what it means. It reads like English. The names aren't just labels, they're documentation. Good variable names are how you turn code from a sequence of mechanical instructions into something a human being can actually understand months later, including yourself. It's the same principle Kurapika lives by. Every chain on his hand has a specific name and a specific purpose. Nothing is generic, nothing is vague. Every tool is precisely what it claims to be. That's how your variables should feel too. So what does it actually mean that your program now has variables? It means your program has memory. It can hold information across instructions. It can track state. It can respond to what happened earlier. Every game that tracks your score, every app that remembers your username, every system that holds onto information from one moment to the next, they all do it through variables. Different types, different names, different lifetimes, but the same fundamental idea. Named slots in memory, holding values that the program can use. Gon's aura isn't powerful because there's a lot of it. It's powerful because he knows exactly what it is, exactly what it can do, and exactly when to use it. Type, name, value. All clear, all intentional. That's what your variables are. The aura of your program. Stored, typed, named, and ready to be used the moment your code calls for them. The container has rules. The container has a name. And the value inside is yours to shape. Don't let this video distract you from the fact that Bungee Gum has the properties of both rubber and gum.